Okay, so we've opened this in StatCrunch. You're literally just going under the graph option and clicking on scatter plot. So just go under graph, click on scatter plot, and select your variable. So in this case, your x is labeled as the x variable and the y is labeled as your y variable. So that's all you have to do is choose your x and y variable and click compute. And you will see it gives you the image of your scatter plot. One thing you can do is if you look at your x and y axes on these graphs, you can see they're going from 0 to 20, 0 to 10, but most of these guys are going from 0 to 10, 0 to 20. So you can adjust your scatter plot if you want it. So you see on your graph at the bottom, you have these 3 lines over here. If you just click on that, you can adjust your x-axis and your y-axis. If you wanted to go from 0 to 10 or 0 to 20, you can do that. And you will see it adjusts your scale on the axis. So again, you can go from minimum 0 to maximum 10. Right now, we'll just do 10 and 10. And you can see some of your points actually disappeared because you have 5 total points over here and only 3 of them are showing. So that means we do actually need to, especially on the y variable, you will see your last number is going up to 17. So the y-axis, you definitely want to go till 20 instead of 10, because actually the last 2 points, 14 and 17, were disappearing. On the x-axis, you're going from 2 to 7. So 0 to 10 works out perfectly. But then on the y-axis, you do need to go up to 20. So you will then get to see those 5 points. So you're generally following this shape. You can kind of see over here, your graph is making this little curve over here. So you can kind of see how these 3 points are making a curve over here, and then these 2 kind of seem like they're in a straight line together. So you're kind of looking for this little curve over here and then the 2 points at the top. So for that, this one obviously is going in the opposite direction because you can see this curve is not in the right position. So this guy is out. And honestly, the only one, these guys are too straight over here. This is not in the right order. So honestly, this is the only one that even has closest to the shape we are looking for. You've got that little curve over here and then these 2 points kind of in a straight line. So you may not see the exact same graph, but you will at least get a very good idea of, comparing the 2 graphs, what our answer should look like. So just do a quick comparison here, check your answer. So this is what I was talking about. Hey, Ileana, we're just working on examples from section 4.2 just before the exam to make sure everybody's comfortable with this, okay? All right. So this is the one where you're using more of a approximation to calculate, what the equation of the line should look like, which can pass through all of these points. So you're just trying to find the line that can possibly go through all of these points here. So what's happening is they have picked 2 ordered pairs from this table. So they've actually gone with 2 and 2 from here and 7 and 17 from the other one. So they're using 2 points and they're asking you to come up with the equation of a line. And this equation is going to be in the form of y equals mx plus b. They're asking you to find the slope. Remember your slope formula is rise over run. So that's y2 minus y1 divided by x2 minus x1. And then remember your y-intercept is that other value, the b value you're looking for. So you can think of this as being my first point. So this can be my x1, y1 value, and this can be our x2, y2 value. So your 2 ordered pairs. So when you put that in your slope formula, you're doing y2 is 17 minus y1, and in this case, y1 is 2. For the denominator, you are doing x2. So x2 is going to be the number 7 minus x1, which is going to be the number 2. So the basic format for this is these two numbers come from the same ordered pair and these two numbers come from the same ordered pair. So just make sure, you know, you're always using them in the same order. So you can see x2, y2, x1, y1. That's kind of how you set up this formula. And then, you know, obviously just simplify the numbers. So 17 minus 2 will give us 15. 7 minus 2 will give us 5. 15 divided by 5 will give us 3. So that's your slope. So that's going to be 3x over here. Plus, we just have to find the b value now. So what I suggest for this one is first go ahead and find your slope. So we've got this part of the equation taken care of. And then honestly, just use one of these points. It doesn't matter which one, and use them for your x and y value. So we'll just go with the simple one here, 2 and 2. So your x value is 2. So this will become 3 times 2. Your y value is 2. So y over here will also be 2. If you use the other ordered pair, then instead of, you know, for the y, you would use 17 here. Our slope, of course, is 3. Your x value was 7. This guy could be 7. And based on that, you can also calculate your b. So it doesn't matter whichever ordered pair you want to use. You know, we're just going with the 2 and 2 ordered pair. So I'm going to get rid of this. But like I said, the other one will also work. So 2 on the outside, 3 times 2 will give us 6. And you're trying to find the b value because that's going to be your y-intercept over here. Can you tell me what our b value will come out to be in this case? If you have 2 on the other side and then 6 plus b on this side.
4.
What else? There's something missing on that. Because you end up
Negative
subtracting,
4?
right? Yeah, very nice. Because you have a positive 6 over here, guys, when you take it to the other side, you always change the sign. And, you know, of course, the two numbers are being added, so we would need to subtract. So you are subtracting 6. And when you move it to the other side, you end up with 2 minus 6. Because, you know, of course, this cancels out on the right-hand side. And 2 minus 6 will actually give you negative 4. So your equation will then end up becoming, and I'm just going to put it over here. So this number here is 3. So that's 3x. Since they're giving you the plus sign here, that means you're actually going to type in negative 4 in that empty space. So you've got your slope and you've got your y-intercept over here. So y equals, let me get rid of my pen here. There we go. 3x and then minus 4 over here. So check our answer. That looks good. And now they're asking us to choose the graph. So we already know what the basic graph looks like because we already did that in part 1. Now they're saying what would happen if you actually put this line on top of your graph, what would it look like? So we can actually go back to StatCrunch for this. We've already got our scatter plot here, and let's keep that equation visible. So leave your graph as it is, go under options, click on edit, and then look at this one over here that says overlay polynomial order. So you will see this equation is in the form of y equals mx plus b. That means your x value has an exponent of 1. Because if you had the equation in the form of, you know, y equals, I don't know, 3x squared minus 4, your polynomial would be of the order 2. When it is y equals 3x minus 4, that means your polynomial is of order 1. So that's what you have to do in your little polynomial order here. You're picking order 1. And then you're actually going with the second option because this is where you will need to type in your slope and your y-intercept. So when they say C0, you will see with C0, there's no x. That means the C0 is the minus 4 from here. So you're actually going to type in for C0 minus 4. With the C1, you will see it's being multiplied with x. So the C1 is actually coming from here, the number that's being multiplied with x. So your C1, you know, of course, in this case will then end up becoming 3. So just be careful about that. Look at the way they're giving you that general form of the equation over here. So the number with the x is your slope. The number without the x is the y-intercept. So type those in. I'm actually going to go ahead and clear this out. So literally just pick the polynomial order, which is order 1. Type in your C0 and C1 values, and then click compute. And you will see it shows you what happens when you overlay that line on top of your scatter diagram. And in this case, we of course notice that this line is passing through 4 out of the 5 points. So only this third point is below the line, but the remaining 4 all fall on the line. So, of course, that's the graph you're trying to match. So just the third point is outside by itself, and then the other 3 are going to be, on the line. So, just to quickly walk you through, you will see all 5 of these points are falling on the line. Not good. This one, our points are in the other order because you can see the third point is here at the top and it should be at the bottom. This one also is in the opposite direction because the third point was below the line, not above. So the only one that even gets close enough is this graph over here. And let's see if I can put both of them on the same page, or at least the same screen. So yeah, here you can see these guys are looking good. Your third point is below the line, your third point is below the line, and all 4 of them are on the line. So that's the best graph we have, which was graph C. And you check your answer and we're good to go. So remember, guys, this equation we came up with was just an approximation based on 2 of the ordered pairs that they are giving you, in this table. So this is at best just a good approximation, but this is not, the best fit as we talk about these, regression lines. So that's actually what they're having you calculate here, is when they say by hand, determine your least squares regression line. And the easier way that I found to work with this was actually in Excel or Google Sheets, whichever program you're comfortable with. So just click here. If you're doing Google Sheets, you will need to do copy to clipboard. But if you're going with Excel, then, of course, just say open in Excel and it downloads a file. So just click on that. You will have to give it permission to edit because they always open up as, just viewing or read only files. So just, go to the top here and say enable editing if you're using Excel. Now the least squares regression line has a formula of y hat equals b sub 1 times x plus b sub 0. We define b sub 1 as our correlation coefficient r multiplied with the standard deviation of the y values divided by the standard deviation of the x values. And you can actually find these formulas in your textbook. That's where I got these from. For the b sub 0, you have to take the average of the y value. So that's the y bar. This is the average of the y values. And from this, you are subtracting b1, which is this, variable you're calculating here. So you take b1 and multiply it by the average of the x values. So basically, you're finding the standard deviation for x and y, and you're finding the average for x and y. So let's do the average and standard deviation calculations here. And remember, by average, we mean you're calculating the mean values and then the standard deviation for both of them. So let's start by calculating the mean for the x. So remember, that's the built-in function of average. And then just select all your x values. So that's the average for x. Same repetition here. We're finding the average for the y value. So again, use your average function and the average of those 5 points. When you're using the standard deviation, remember this is again a sample, not a population. So use the .s function when you're using the built-in function. So same thing, find the standard deviation for x and then find the standard deviation for y. So that takes care of 4 of these variables. You still have to find the correlation coefficient of r. So for the r value, remember the built-in function is correl, C-O-R-R-E-L, correlation correl. So for this one, you have to choose both the x and y values. So remember, for the first part, go ahead and select your x values, comma, then go ahead and select all of your y values. And you do have to select the entire column for the x and the y. So x values first, y values second, and that's it. That's your correlation coefficient. So we actually have all the components now, but now we need to calculate the B1 and the B0 value. So let's do that next. We'll start with B1 because without B1, we cannot find B0. So B1, we start by equal to, you're multiplying by the correlation coefficient. So that's the R, which is this 0.99. You will see I'm not rounding the numbers. I'm not doing anything. I'm just leaving them as our spreadsheet gave them to us. So multiply the R value with standard deviation of Y divided by the standard deviation of X. So you can see I took the cell where I have all of these numbers and I'm just letting, Excel do the calculations for me. So this will give you the B1 value. So just to kind of show you where this number falls, this B1 value you just calculated is actually going right here because your B1, remember the general format is B1 times X. So you can see B1 times X. So that's the number that goes here. And then the number we calculate for B sub 0 is going to go over here, which will be, the second one. And compare that with the values we had from this approximation equation we did at the first step. So that's kind of where we are, with these B1 and B0 values. So coming back, we've got our B1 now. Let's calculate the B0 or B0. So looking at the formula, you will see we start out with the average of the Y values. So that's the 8.8 number here, minus you multiply B1, which we just calculated as 3.046512. So you're doing average of Y minus B1 multiplied with the average of X. Okay, so average of Y minus B1 times average of X, and that gives you your B0. And this will now be our equation. So Y equals, and I believe they want us to round this to 3 decimal places. Yeah, you can see they want us to round these to 3 decimal places. So I was actually showing Mary how to do this. If this is something you guys are not familiar with, click on the cell that we just calculated for B1, and you will see right over here is actually where you can add or subtract decimals from your answers. So you will see it's right under this general box that you have. So if you want to subtract the decimals, which means have smaller decimals than what's visible, click on the one on the left-hand side. Right-hand side. So this will decrease your decimal, and we just want to do 3 decimal places. So you can see 3 decimal places, we get 3.047. Same thing with the B0 value. I want to decrease my decimal to 3 decimal places. So my equation will now become 3.047. And remember, this is the one where you multiplied with X plus the B0, which is negative 4.605. So this is what our new equation will now end up looking like. And this is what they're asking us to type in here. So B1 goes with the X value, and that was 3.047. B0 is the negative 4.605. And again, guys, if you do the little comparison between the equation we got before and the equation we have now, you had 3 as your slope. We have a little bit more of a better approximation because you've got 3.047. You had -4 as the y-intercept, and now with the regression line, we've got -4.605. So you can see you get a good, decent approximation when you just use the 2 ordered pairs, but with the least squares regression line, you get a little bit better and closer approximation than you would with just using those 2 points. So that's kind of what we were going for over here. So they're actually asking you now to see what happens when you graph this new line with your scatter plot, what it will end up looking like. So for this part again, let's clear this out. For this part again, we can actually go back to StatCrunch here. And go under options again, edit. And you're actually going back to this same polynomial order we did over here, but now put in your newer approximation. So remember, for our slope, you've got 3.047. So just change that number. With the y-intercept, you had -4.605. So again, just update those numbers, click compute, and you will see your line changes a little bit here. So now you will notice these 4 points are no longer on the line. They're actually a little bit above the line. So you will see 4 of these points are above the line, and that third point is still below the line, kind of like what you had before, but it's changed a little bit. So this is the graph you're looking for, those 4 points above the line, and then this third point here, below the line. So let's see, what our graph looks like here. You know what, I will clear this out. So the third point has to be below, which means this guy is the only one that's even looking close enough. This point is obviously in the incorrect order. It's above the line here. The part A is also, the third point is above the line. So this is the only candidate that's even close enough. And you will see when you expand it, those 4 points are definitely above the line, and this one is below the line, and that's the closest you are going to get to this graph that we came up with here in StatCrunch. Okay, so this was graph C in our options. So let's check that guy. Looks good. Now this is where they actually want you to calculate. And I again kind of think of this as, how we were talking about margin of error in the last chapters. I kind of think about this as a sort of a comparison, because you want to know from the 2 lines that we came up with, which was based on these 2 equations, which one is the best fit, which means from the line, which one has the least distance above or below the line. So which one is a better fit? So that's the residual you're calculating. So you will get 2 questions on this. The first one here is asking you to calculate the sum of the squared residuals based on your equation in part B. So part B was this equation here, the 3x minus 4 equation. So I actually like using Excel again to do this calculation, because again, those auto calculate really helps you out. So let's start by calculating our y hat value first based on the equation 3x minus 4. Again, remember guys, this is coming from this part B equation. 3x plus and minus will become minus, so that's 3x minus 4, and that's the equation we are using. So the first thing you are going to do is calculate the y hat, and we use y hat as the notation because this is not the original y equation. This is an approximation that you're coming up with. So that means you are actually calculating what the new y value will be based on the original x value. So in this new column, you're going to do equal to 3 times, that's your slope, multiplied by the original x value. So I'm just clicking on the cell where my first x is, and then from that you are subtracting 4. So you will see I have equal to 3 times x, which is the number I have in that cell, minus 4. And this actually calculates your new y hat based on this equation. Once you type that first equation in, remember, take your mouse and you will see how that plus sign is going to change. Right now, it kind of looks like, a fat X. And then when I move it to the bottom right of the cell, it changes to this black, skinnier cell. So once you get there, just click and drag your mouse till you get to the bottom of that table. And you will see for each one of these cells, it's taken 3 times that X value minus 4. So it calculates all the new Y values based on, this new equation we have from part B. Once you calculate the Y hat, our next step is going to be taking the original Y value and subtracting the Y hat from it. Because now we're trying to figure out, sort of that margin of error. How far away are you from, what you had in the table, and then based on this line that we calculated. So that's going to be your next column. So I just call it Y minus Y hat. So literally take the number from your Y column first, because that's the original Y value, minus the Y hat we just calculated. So Y minus Y hat is going to be your second one. And of course, 2 minus 2 is going to give us 0. 5 minus 5 will give us 0. 14, 17, all the same. Only the difference was right here. You had 6 and 8. And that makes sense. Think about this, guys. In this first graph that we had from the first line, all 4 of these points were right there on the line, right? So they passed through the line. The only one that did not was this third point. You can see this point was below. And so it's no surprise that this is the only point where you ended up getting any answer. All the others came out to be 0, because this is that third point, which was not on the line. It fell, below the line. So that's the -2. Okay, so we've calculated the residual. So literally, this is exactly as it says. We have calculated the residual. Now, the next thing we have to do is square it. So coming back here, we're going to do the square on this. So literally take the answers you got from the Y minus Y hat and square all those numbers. So, and this guys has a bunch of zeros, but that's not always going to be the case. So take the number, multiply into itself. So literally just that column of Y minus Y hat, you're taking those numbers and multiplying them into themselves. All the zeros will be zeros, but -2 times -2 will give you 4. So this is the square of the residuals. And then the very last thing they're asking us to do is find the sum of the square of the residual. So you've done the square of the residuals. Now the last part you are doing is taking the sum. So add that column up. So just use the built-in sum function. And of course, you can see this guy's just going to add up to 4. But again, if you had different numbers for these other 4 numbers, you can add all of them together. So this is the sum of the residuals they're asking. And they, I think, are still doing 3 decimal places on this. It's going to come out to be the number 4. If they don't accept 4, you can do 4.000. Just to be safe, I'm going to type in those 3 extra zeros so we don't have to worry about that. And that came out great. Now you're repeating the same exact process, but using the equation from part D. They're still asking you to find the square of, the sum of the squared residuals based on your least squares regression line, which is going to be this equation now. So literally, we're just going to change this part of the equation and do 3.047 times x minus 4.605. And again, guys, you will see, when we do this with Excel, it makes our calculations go a lot faster than, having to do this by hand. So I'm just going to copy this over and repeat the calculation. So start by calculating your y hat first. So that will be equal to 3.047. Multiply this with your original x value, okay, minus 4.605. So literally, where you had 3 times the cell minus 4, you're now changing it with 3.047 times the x value minus the 4.605. And you will see, compared to these numbers, these numbers will be a little bit different because our calculation has changed. So again, take your mouse to the corner of that cell, drag it till you get to, all the numbers over here. Let's get rid of these extra lines for now. And you will see we're close enough to these y hat values from the first equation, but yeah, there is definitely a slight difference. Now you do the y minus y hat, so equal to original y value minus the new y hat you just calculated. Okay, so again, original y value minus the new y hat based on the equation from part D for, David, part D. Bring this down. Now look at that. All of these distances was 0 except for that third point where you had -2. But now with this better approximation, we don't have zeros anywhere, right? Now the next part is where you take the square of these subtractions. So 0.511 multiplied into itself. That's going to be the square of our residuals. Bring that down for all of these numbers. And then the very last thing is where you add the square of these residuals. So we are using the sum function to add all 5 of these numbers. And look how different your residual comes out to be. Because you have a better approximation, guys, that means that this new line that we have from part D, the least squares regression line, is actually telling you that this line fits a little bit better. Even though none of your points were passing through this line, it means you've actually found a good fit where all 5 of those points are now, equally balanced out with the distance from the line to the points themselves. And that is what these residuals are telling you, that this second line we came up with, the one you see on your screen here, is a better approximation. So we also need to break this down to 3 decimal places. So 3.163 is going to be your new squared residual. So 3.163. And then the last part is just putting in a conclusion. So they are saying the line in part B or D passes through most points. And we know that's this line from this part B, because this is the one where you had 4 points out of the 5 that passed, that the line passed through. So 4 out of those 4 points, 5 points. So part B is where your line will pass through the points. However, the equation from part D is giving you the smaller residual, or the smaller squared residual, because obviously you can see our number for part D was smaller than the one from part B. So we will say the line in part D minimizes the sum of the square residuals, because again, this is the smaller number from part D that we calculated. So that means this line that we got from here, which is this line you see over here, is a better fit than the line we got from this part over here. So that's what they're saying. It's a better fitting line from the equation in part D. So that's kind of how they're having you do. So it doesn't mean that if your line has the most points is a better line. It means which one gives you the smaller error from the points to the line itself. So does that kind of make a sense between the two equations we calculated here? Yeah. Anybody have questions on any part of this calculation, especially this one here, where you're calculating this least squares regression line? So again, remember, for this part is where you calculate the mean and the standard deviations for each one of these X and Y columns. Find your correlation coefficient, and then based on that, you calculate your slope and y-intercept for the line. Okay. One more example that I had kind of shortlisted was, I kind of liked it because they were doing, I believe it was a comparison. And of course, you guys have seen that in your homework. I think it was because it was based on drivers, I think. Yeah, I think it's this one. Yeah, the table represents the number of licensed drivers in different age groups, and the number of fatal accidents by different age groups. So yeah, they broke it down by male and female drivers over here. So you can see on the left-hand side, they're giving you the different age groups, and then they're telling you how many of the male drivers were licensed. And this actually means you're in thousands. So this is actually 12,000. This will be 6,424,000. So that's how they have this. And then this is the number of fatal crashes for males. Then this is the number of female licensed drivers, and then the number of fatal crashes made by females. So that's kind of how they're breaking this table down. So the first part they're asking us here, is, let's close this for now. They actually directly start out by asking us to find the least squares regression line for males. And this is where they're telling us to treat the number of licensed drivers as your explanatory variable, which means your independent variable or the X variable, and the number of fatal crashes as our Y variable or the response variable. And then they're saying repeat this process for the female drivers as well. So you're directly going into the least squares regression line. So remember, that's this one that we looked at in the previous example. And remember, B1 is your correlation coefficient multiplied by the standard deviation of Y, divide by the standard deviation of X, and then your B0 was the average of the Y values minus B1 times average of the X variable. So basically, we need to start by finding our mean, standard deviation, and of course the correlation value. So I am actually going to take this, click on the table, and I am going to move this to Excel again and just use those built-in functions to help us out with the average, standard deviation, and all of that. Okay, so make sure you're enabling editing. And let's get rid of some of these lines here. Okay, and I'm going to leave the equation so we can have that to look at. So remember, we're using the licensed drivers as our X values and the fatal crashes as our Y values. So we'll start by finding the average or the mean over here. So let's do mean for each one of these columns. So that's our function average for the licensed male drivers. And again, since I'm calculating the average for all of these columns, I'm going to go to the bottom right corner of this cell. And instead of dragging it down, I'm actually going to drag it right till I get to the very last column. And you will see when you click on this, this is using all the data cells from here. This one is using all the data cells from the female licensed drivers. And this one is using all the data cells from the fatal crashes for females. So just type one function and then you can copy it over to the others. So that was our mean. We'll do the same thing for standard deviation. Treat this as your sample again. So I'm going to use the .s function. Select all the male licensed drivers. And then just like I showed you, go to the bottom right and then drag it all the way to the right. Oh, one more. There we go. So again, it's calculating the standard deviation for each one of our other columns. So just to verify, click on that, and you can see we have the right values. So mean is done. Standard deviation is done. Now this is where we need to calculate our correlation coefficient. So remember the built-in function is CORREL. Now this one, we will have to do for each of the males and the females. So you know what? I'm going to write this as the correlation coefficient for male. Okay, so remember we're using the licensed drivers as our explanatory variable. So that's the first array. And then the fatal crashes as our response variable. So that's the second array. So you're going to be doing just for the male drivers, licensed versus fatal. And then we'll need to repeat the same process for the females. So our coefficient females, so CORREL. And then same thing, the first array will be the licensed drivers. And then the fatal crashes will be the second array. So we've now got all the numbers that we need to make these calculations happen. So as you can imagine, we're going to have one regression line, for the male drivers and one regression line for the female driver. So that means you will be calculating the B1 and the B0 for each of our data sets. So B1 and B0. Alrighty, guys. So this is where you now need to use the formula. So let's start with B1. So equal to, you first take that coefficient correlation number, multiply that by the standard deviation for the Y values, which in this case is going to be the fatal crashes. Divide that by the standard deviation of the X value, which in this case will be the licensed drivers. So just kind of keep that in track. If you need to make a little key so you remember which is your X and Y, you can do that also. But this is going to be our B1 value for the males. Now let's do the B0, and this is going to be equal to, now remember this is where you're taking the average of the Y variable, which will be the average of the fatal crashes, minus B1. Remember this is the number you just calculated, so that's the 0.309 496097. So let's see, average of the fatal crashes minus B1 multiplied with the average of the licensed drivers. And this is all happening for the male drivers. So we need to reduce this down to 3 decimal places. I think it was 3. Okay, let's click continue. Yeah, 3 decimal places. All right, repeat the same process here for the female drivers. So equal to, we're calculating the B1. So again, start with your correlation coefficient. So that's this number here. You are multiplying that with the standard deviation of Y, which of course will be standard deviation of female fatal crashes, divided by standard deviation of the licensed drivers. Okay, so that's our B1. Now for the B0, you're taking average of the Y values, which is the fatal crashes for females, minus B1, that's the number you just calculated, 0.085669476, and multiply that with the average of your female licensed drivers. So you're literally following these two, B1, B0 formulas I have written down here. And you can see you know, what these numbers are coming out to be. I'm going to again decrease them to 3 decimal places. And I mean, just look at those B1 and B0 values between the male and the female drivers. You know, those numbers are significantly smaller on the female driver side as it is to the male driver. So now let's go ahead and put all of this in. So we're starting out with the males first. Let's see if I can have this here. So for, remember, B1 is the number that goes with X. So that's the 309 or 0.309. So that guy goes here. Your Y intercept is the B0. So that's 1361.561. You know, I wonder, you can try copy and paste. I've never tried that, but it probably works. 1361.561. Oh, sorry, I did this when I was doing the example. My bad. They wanted 3 decimal places for the slope. So this guy is right, but they actually want constant rounded to the nearest integer. So this one actually does not need to be 3 decimal places. This needs to be a whole number. Forgot about that. So for both of these, we actually need to round this to no decimal places. Okay, so let's get rid of all of those decimals, whole number. And same thing here, we want to make this guy also a whole number. Okay, so this will actually become 1362. What did I do? Three decimal places for the slope, constant to the nearest integer. We did male. Yeah, that's my correlation coefficient. Oh, I do not believe I did that. Okay, I don't know if you guys see, but I left my first row out. So this should, what are you doing, buddy? Okay, I'm gonna retype this in. So this actually needs to be from the top to the bottom. I don't know how I did that. So it will end up changing my numbers. Man, I just cannot seem to work this. Okay, yeah, so my numbers did change a little bit. I'm going to confirm and see I did this. Yeah, I made the mess here also. So that should be from 2 to 10 and from 2 to 10. So hopefully that'll fix my answers. Okay, sorry about that. Didn't pay attention. So 331 is actually what you have here. And this one changed to 1126. Okay, 331, 1126. And it still didn't count it right. Okay, that was our mean. And it selected the entire table. Oh, our standard deviation was also wrong. No wonder. Okay, standard deviation. Probably the same thing happened here. That's our average looking good. And yeah, I didn't have the 2 in there. Okay, so now you will see our answers will match the 342 and the 1004. This is going from D2 to D10. That looks good. Same thing happened here. I left out my first row, so this should be fixed. On the fatal crashes side, we have 2 to 10, so that looks good. And I'm sure we need to fix this guy. So 2 to 10. This looks good. And then hopefully, since we fixed those numbers, these would be fixed too. And this is another reason, and I know I've kind of mentioned this in the past. This is the reason why you will see I always use the cells instead of typing the numbers in there, because one calculation goes wrong. Obviously, the others go wrong, but when you fix it, it automatically does the rest of the calculations for you. So, you don't have to go back in and change any of the numbers, because once you fix one of those cells, it automatically will recalculate all the other numbers. And that's another reason why, these spreadsheet programs work out really well. So hopefully we should be good to go on these, equation for the females over here. So that's the next one they want us to type in. So our B1 value is 0.105. So let's put that in here. And then our constant for the B0 is 512. So I'm really hoping I did not make any more mistakes, and that guy looks good. So you've got your regression lines. Now the next part they're asking us is to interpret the slope of the least squares for each gender, and how might an insurance company use this information. So, basically looking at the two equations that we have over here, they're asking, and we'll have to click on continue to see the options. So they are saying, and this is based for the males, male drivers first. So they're saying if the number of male licensed drivers increases by 1,000, then by how much will the number of fatal crashes increase? So that's the first one. They're saying if the number of fatal crashes increase by 1, then, by how many more licensed drivers will you have? Part C is saying if the average of all male licensed drivers increases by 1, then the number of fatal crashes will increase by what on an average? So you can see almost the same language in all of them, but there is still a little bit of a distinction in parts A, B, C, and of course the D is saying none of this makes sense, which I will tell you right now is not an option. So you have to choose between A, B, and C, and which one, even without putting the numbers in, seems to be the option we should be going with.
A.
Yeah, because this is the only one which is talking about in 1,000. And remember, in your table, they are giving you this data in thousands for the male and female. So really, that's the only option that even makes sense over here. So you are going with A. And the slope is basically telling you if the licensed drivers increases by 1, then that means your number of fatal crashes will increase by a fraction of 1, which is going to be 0.342. Because that's just telling you, the comparison, what kind of growth rate are you having from the licensed drivers to the number of fatal crashes that happen. And, obviously we'll be doing basically the same thing with the female driver's license. So that's going to be a factor of, 0.105, because that's the slope on the females. So same thing, you are going to go with the option that again is talking about in terms of thousands. So this is going to be if the number of female driver's licenses increases by 1,000, then that means the number of fatal crashes will increase by 0.105. Because, the more licensed drivers you have, of course, we do expect the crashes will also go up. So you do see kind of that direct relationship between those two. And then this one is saying the slope of the regression line for males. So is the slope greater than, same, or less than from males to females? Because the slope on males is 0.342, the slope on females is 0.105.
Greater?
Yeah, the slope on the males is greater than females. And then they are saying in the next one, let me make this smaller here. So they are saying this means that males tend to be involved in more, as many, or fewer fatal crashes than female. More, as many, or fewer?
More.
More, because if your average or your slope is more, of course, that means you are seeing a higher rate of crashes happening. And they're saying an insurance company may use this information to argue for equal rates, higher rates for males, or higher rates for females. So how will the insurance company base their plan rates based on this information here? Would you
Higher for males?
sorry, Naomi, go ahead.
Higher for males?
Yeah, because if you're seeing a higher crash rate with the males, they're of course going to charge males a higher. If it was reversed, then whoever is making more crashes will get a higher premium. So that's kind of what they're having you interpret here with the comparison that you just did. Now, this next one is basically kind of breaking it down by age groups. So they are saying, was the number of fatal crashes for 16 to 20-year-old above or below average? So remember, your average for the males is 0.342, for the females is 0.15. So they're saying the number of fatal accidents for 16 to 20-year-old males was above or below average. And you know what? I'm just going to open our Excel here so we can do that. Oh, I didn't mean to open you. So between the group of 16 and 20, which is going to be this one right over here, they want to know, are the fatal crashes, hold on, I need to move this file, above or below average? So was the number of fatal accidents of 16 to 20-year-old above or below average? So what would you say? So your average for the fatal crashes is right over here for males. And for the age group of 16 to 20, would you say this is above average or below average? Sorry, not using the slope, but the average itself.
Above.
Above, yeah. Your average for this group came out to be 4,767, 0.333 repeating. And this one is 5180. The next one they're saying, was the number of fatal accidents for 21 to 24-year-old males above or below average? So 21 to 24 is this category right underneath. So still above average, right? Because that is more than the 4767 number you're seeing over here. Then they are saying, was the number of fatal accidents for males greater than 74-year-old above or below average? And that's going to be this last group over here. And you can see for people older than 74, you're looking at a number of 2022, which of course falls below your average for this group. And how does that relationship hold for female? So we'll have to click on continue before we can go on. So the number of 16 to 28 was above average. The number of 21 to 24 was also above average. However, for males older than 74, that number was below average. And it makes sense, right? I mean, there's going to be less drivers, as you can see, who are driving in that age group. So if you have less drivers driving, you will have lower number of accidents. But, obviously, hopefully people are far more experienced at that age to be more careful. But there can be other reasons going on in there. Okay, so now they're saying, how will the insurance company use this information? So the insurance company could use it to argue higher rates for which generation, the older or the younger? Who would they want higher rates for?
Younger.
Yeah, because, obviously they have more accidents that are happening, and lower rates for the older ones because they're not having as many accidents. So again, how do you interpret that information? Is this relationship the same for females? So for females, let's move over here. Fatal crashes on an average are 1,661. This is the age group for 16 to, I think 20. And this is the age group from 21 to 24. And this is the age group greater than 74. So are those first two, 16 to 20 and 21 to 24, are they above average or below average?
One's above and one's below.
Yeah, one is above and one is below. And then of course, for females greater than 74, you can see again, they are below average because they're only at 959 instead of the 1661. But it's almost the same because the 16 to 20, of course, were having crashes which were above average. So in this case, we will actually say same. It does hold for the females. So guys, you can see really the main calculation you had to do here was just calculating those regression lines for the two groups. And then after that was literally just interpreting the information you had and, you know, kind of looking at how would the insurance company use that information to come up with the answer. So a lot of the questions were just making sense of the calculation. So the big part you really had to do was just calculating the mean standard deviation for each group, calculating the correlation coefficient for both groups, and then, you know, obviously coming up with your two equations, so the B1, B0 values for both the groups.